In this video, we'll look at trig graphs and particularly these very bizarre questions that often give students a bit of a headache. Fx times gx is less than naught, or even worse, the derivative of f times g is bigger than naught. And so I've drawn the two graphs for you here just so that you can see exactly what they look like, because I want to spend most of our thinking energy into what's going on here. So for starters, when you have f times g less than naught, all that you're thinking in English is just where are the graphs in different places, because if this was a plus and this was a minus, times together it would be less than naught. Conversely, if I had f times g and I was asking you where is that bigger than or equal to naught, for something to end up positive, these signs of the graphs would have to be the same. And so all I'm looking for in English is where they're in the same place. So that makes a huge difference. If when you see these, you just think less than naught, different. So in the beginning, they're both above the x-axis. And by different or same, I mean, are they both above the x, both below, or in different places? I'm looking where they're different. In the beginning, they're in the same. They're both above the x-axis. Then from 45, the one graph, the fx graph, the purple one, dips below. So now they're in different places. Gx is above, fx is below. So they're different, and let's try to see where they start to be the same. There, at 135. At 135, both graphs are now just above the x-axis. And that only lasts until 150. What happens after 150, if you look visually? The G graph, the blue one, is below. The F graph, the purple one, is above. So in English, you'd say they're in different places. And that's what I wanted. I wanted where they're in different places. So that was from 150 until 180. So I hope that's helpful just to understand, looking at it, where they're the same and different. What do I do when there's a derivative? That's got to do with the gradient. And so the F graph is the purple graph. And so I'm going to look in two places. Let me just think of it separately. I'm looking where the gradient is going down, and at the same time, because it's bigger than naught, so I'm looking for the same situation where the gradient is going down. At the same time, the other graph would have to be below. You've heard that said before: down, below, up, above. And so that's the other option I look for. Where the F graph was going up, then my G graph must be above. And so that's how you deal with the issue of derivatives timesing other ones. So where they're in the same place. So let's look at it. In the beginning, the F graph is going down, and I should be looking where the G graph is below the line, but the G graph's always above the line for that portion. So I'm not going to get an answer at all out of this. The other answer will come when the F graph is going up. So that's the rest of the graph from here to 180. So all of that, it's going up. So all I'm looking for is where the other graph is above the line. And the other graph is above the line all the way from 90, it's above, it's above, it's above, to 150. And so that would simply be my answer. I find this personally quite helpful, just to think down, below, up, above, and that hopefully gives you a nice insight into what to do with these weirder looking questions that give one a bit of a headache from time to time. I hope you found this helpful. If you did, please like this video, subscribe to our channel, and share this with your friends. Thanks.